Do you ever thought about what exactly are the process by which dirty wastewater converted to drinkable water? Hello friends, welcome to my channel Knowledgeopedia. My name is Kuntal Ganguly and you are with me to discuss about different basic steps to convert wastewater to drinking water within a very short time. There are mainly 6 major steps during the entire process we are going to discuss, which are screening, aeration, sedimentation, filtration, disinfection or chlorination, and softening. Let us start our discussion with the first step, which is screening. Screening are mainly conducted into two or sometimes as three different parts: primary screening, sometimes secondary screening, or intermediate screening. Primary screening: at start, raw water passes through a primary coarse screen which removes large size floating particles with sizes above 25 mm. The entire water flow through screens are normally restricted to 1 meter per second, starting from point 1 or sometimes 0.3 meter per second. The screens are always placed into 30 to 60 degree angle so that maximum water could get touch into it. With the method of rotating upwards chain system, all arrested particles collected in a separate chamber. Further, water passes through fine screening, which usually separates the small floating matters or sizes up to 3 mm sizes. The separated particles then similarly collected and used for separate purposes to create fertilizer, and in some advanced level plants, dry sludge heated at 38 degrees centigrade temperature and fermented for a week, and microorganism breaks down organic substances to create methane gas and carbon dioxide gas used for other purposes. The next step after screening is called aeration. In dirty sludge water, oxygen percentages comes down to very low level. As we know, in healthy drinking water, a minimum level of dissolved oxygen is required. Water lives are able to sustain by using that dissolved oxygen and maintain the water ecosystem. Here in this process, oxygen is injected through aeration point and a healthy oxygen level are restored in the water. This helps fishes and other aquatic life to survive. During aeration process, it is ensured that water to come at maximum level of air contact by creating droplets, so that water level could be increased in water by removing dissolved gases like carbon dioxides. It also oxidizes dissolved metals such as iron, hydrogen sulfide, and volatile organic chemicals. The arrangements done in a chamber, as you can see, is called aeration tank. Below such chambers or tanks, multiple numbers of aeration nozzle placed. Through this, air and oxygen are injected from the bottom, creates maximum effective result. The next process is called as sedimentation. As in first step, we already have discussed about removing of floating type of particles. Here, we are in this process to eliminate large size sinking particles. The sedimentation process could be divided into two steps. The first one is primary sedimentation, and the second one is sedimentation with coagulation. We know that in stable water, bigger and heavier particles normally settles down and lighter particles keeps floating. Similarly, in this process also, water is slowly filled in a conical bottom tank through the middle pipes shown here. In bottom stable condition, large sinking particles settles down which are taken out through a drain pipe. The oil substances are wiped out from water with the help of flow-through channel wiper. Here also have same type of arrangement of collecting dry sludge. The comparatively clear water overflows from the tank to side bay and goes for the next level of sedimentation process, which is called as sedimentation with coagulation or flocculation. The overflown water after primary sedimentation further goes to second level of sedimentation process, which is flocculation in the flocculation tank. The sludge particles which are not yet been able to settle down in primary sedimentation tanks are removed under the process through flocculation or coagulation. To settle down small and lighter particles, a very known coagulant is used as in water industry, which is called as alum. Alum creates a bundle of lighter and smaller impurities of particles by joining themselves. In technical terms, which is called as flocks. Further, polymer solution like ferrix is mixed in the water tank, which helps to convert microflocks to macroflock. It is then mixed with the help of three-stage agitator inside tank with different speed of rotation, resulting increased weight of bundled substances settles down in the bottom of the flocculator or sedimentation tank. The tank creates this phenomena of creating flocks are called as flocculator, and the process of mixing coagulants like alum and polymer is called as coagulation. The further comparatively clean water collected by overflowing them from the flocculation tank to flow through channel, same by primary sedimentation tank, goes for the next level of purification.
The next step is known as filtration process. The ultra-small suspended impurities, which are yet not removed even after coagulation, are removed under the process of filtration. The procedure occurs inside a tank of round or square-shaped pit. Under filtration process, water is passed through bed of sand and other granular materials like gravel. 95 to 98% suspended impurities are removed by sand filtration under this process. It is used for removing bacteria, color, taste, and odor. As you can see in the block diagram of the tank design, water comes from top level, follows through primary layer of coal and sand. It follows through garnet and coarse gravel. The flow through water further passes through multiple perforated lateral chamber filters. The entire filtration process effectively removes 98 to 99% bacteria and turbidity level brings down to as minimum as 1 NTU. From outlet of filtration tank, the purified water goes for next level of purification step, called disinfection or chlorination. As of now, we learn about the different processes of removing non-living impurities. But there are many living organisms lives in the water which could be very harmful to human body, like virus, micro-level bacteria which cannot be seen in open eyes without microscope. The process to remove such living impurities are known as disinfection. There are two methods of disinfection: physical and chemical. In chemical method, mainly chlorine gas along with bromine, potassium permanganate, ozone and lime are injected as disinfection agents. This process also known as chlorination. Chlorine gas and other chemicals are mixed in a systematic manner through various flow-through chambers so that all substances are properly mixed, same as we can observe in this video. After chlorination, water color turns into blue. The gas mixing occurs from the bottom as per the diagram. The flow through water then goes out of chamber through the pipes and follows through for next step. The next and final step is called softening. As we observed about build-up of minerals or scale inside of pipes, fixtures and hot water heaters creates major damages to the home and industrial appliances. The characteristic of such water called as hardness. When hard water and soap are mixed, the magnesium ion reacts with soap molecules and forms a solid material called a precipitate, which does not dissolve. This precipitate or soap scum reduces the ability of the soap to make bubbles. The Drinking Water Inspectorate says that water with a sodium content of up to 200 ppm is safe to drink. To achieve this level, final step of softening are carried out. In simple word, soft is the opposite word of hard. And to make water soft nature from hard nature is called softening. There are 4 steps of water softening: ion exchange, salt-free, reverse osmosis and magnetic. Out of all these, ion exchange by using zeolite is widely used and cheap process. Zeolite softening process is the process of removing permanent as well as temporary hardness of the water. Zeolite softening occurs when magnesium and calcium zeolites, which is insoluble in water, get precipitated. So, by now, I hope you all could understand the step-by-step procedure to make wastewater to safe drinking water. Please have a thumbs up to my effort, enjoy your glass of pure water and don't forget to subscribe my channel for more interested videos every Friday. Thanks for watching.